Good morning all. We'll just look into the scattering process. Always the experiments on scattering particles employ the following type of arrangements. That is, a parallel beam of particles of a given momentum is directed towards a target. So we'll just call this a target, which deflects and scatters the particles in various directions. These scattered particles diverge. As you know, it will diverge to different directions. It's like when you pour some water, you use a hose to pour water, or for watering the plants. Then if you hit a stone, what happens? It gets scattered in all the directions. So similarly here also, we consider a particle, a beam of parallel beam of particles which hit on the target and gets scattered in various directions. Or we can say that the scattered particles diverge. So at large distances from the target, their motion is directed radially outwards. Okay. The theory of scattering is developed against this background, or this general picture of scattering process. So here we have to choose a coordinate system. And here what we do is, the origin we fix it as the target. Okay. Here we fix the origin as the target. This is the target. This we call it as the scattering center. Okay, this is called the scattering center. And with the Z axis in the direction of the incident beam, so this we take it as the Z axis, which is incident on the, which is the direction of the incident beam, and the direction of the scattered particles then can be represented by the polar coordinates, that is polar angles. They are theta and phi. Okay, with the Z axis taken as the polar axis. This theta is called the, theta is called the angle of scattering. Theta is called the angle of scattering. So I just make a point here. Okay, the angle, I'll draw a line to this point. Okay, then this angle, that is Z axis, which it makes with this, is the scattering angle of scattering, or scattering angle also. So it is an angle between the scattered and the incident direction. So what is angle of scattering? Is a angle between the scattered and incident directions. These two directions together define the plane of scattering. Okay, So plane of scattering means, I'll just draw that. From here you can consider the plane containing, okay, the scattered direction and the incident direction. So this is called the scattering plane. Or plane of scattering. Now you have this phi. It is called the azimuthal angle. It is called the phi is called the azimuthal angle. It specifies the orientation of this plane of scattering, with respect to some reference plane which contains the z-axis. So azimuthal angle, we can draw it as, okay. So it is the angle between the scattering plane, okay. I'll just take a point here. So I'm going to draw a line here. And then some reference plane, okay. I'm going to have a reference plane. Make a point here. Okay, here this I'll draw a line here. So this angle, okay, this angle is called the phi. Okay, that's a azimuthal angle. It is the angle between, you can just tell that, the scattering plane and the reference plane. Okay, that's called the azimuthal angle. So these are the terms which we come across while learning the scattering theory. That is, the target called the scattering center. I mean, this process should be accommodated in a coordinate system, and here the coordinate system is nothing but the polar coordinate system. And you know that you have r, theta and phi. Here r, we have that the incident axis, which we call it as z axis. We take it in the as a z axis. Theta and phi. Theta is the angle of scattering. So angle of scattering is the angle between the incident ray and the scattered direction. Then you have the azimuthal angle. Before defining the azimuthal angle, you have to define the scattering plane. Scattering plane is nothing but the plane containing the z axis and the angle of scattering. And azimuthal angle is the angle between a reference plane which should contain the z axis or the incident axis and the scattering plane. So these are the terms which we come across in the scattering theory. Now let's consider the scattering experiment, and we assume that a steady incident beam is maintained for indefinitely long time. So incident flux, okay, what do you mean by incident flux? Incident flux, and we keep it a alphabet F. It is a number of particles crossing unit area taken normal to the beam direction per unit time. So incident flux is nothing but the number of particles crossing unit area taken normal to the beam direction per unit time. So we always go tell that there's a steady flow of incident beam for a long time, which means that we will have a steady stream of scattered particles also. So now we start assuming that delta n, okay, delta n is a number of particles scattered into a small solid angle d omega about the direction theta phi. In time dt. And then we know that delta n must be proportional to d omega. Okay, what is d omega? Is a particles which are scattered into the small solid angle, and dt is a time, and of course it depends on the number of particles, incident particles also, and that is your F. Now this proportionality factor can be replaced by the differential scattering cross section, which we denote by d sigma by d omega. And this cross section is, sigma term is dependent on theta and phi. So we can write now delta n is equal to, proportionality is replaced by d sigma by d omega into d omega dt and so d sigma by d omega is known as the differential scattering cross section. So this differential scattering cross section depends on the parameters of incident particle and the nature of the target. So given this information, the aim of scattering theory is to always determine the value of d sigma by d omega as a function of theta and phi. Now to get, this is the differential scattering cross section. So in order to get total scattering cross section, what we will do? We have to integrate this. Okay, so sigma is equal to integral d sigma by d omega times d omega. So this we can write it as, it is dependent on r theta and phi. So you have 0 to pi d sigma by d omega sin theta d theta d phi. So always we consider that in our theory we consider d sigma by d omega is independent of phi. So what happens? Phi becomes a constant, and then you can write it as sigma is equal to integral d sigma by d omega. So phi is 0 to 2 pi. So you have the 2 pi term here, sin theta So this is the total cross section, scattering cross section. So this is very important. Delta n is equal to d sigma by d omega, delta omega dt into f. So this will give it as equation 1, and this is as equation. So now in the next lecture I will be dealing with the wave mechanical picture of scattering. That is a quantum mechanical. This is a classical theory. So we have the quantum mechanical picture of scattering, and there we introduce the scattering amplitude. Okay, thank you.